charge, and hence our outward.
See, when a positive charge is kept here, these are the electric field lines. Outward, positive charge, we know field lines are normal to the surface and outwards. These are the field line, electric field line. These arrow marks represent electric field line. Why it is drawn outward? Because this is positive charge. That's why it is drawn outwards. Okay.
Outwardly normal to the sphere at all points on its surface. The magnitude of the electric field E at a distance r from the point charge is equal to 1 by 4 pi epsilon naught q by r square.
That equation we have studied. The electric field at a distance r from a point charge. What is the equation, children? What is the equation? Electric field at a distance r from a point charge. I don't know how to do it. Krishna Prabha, what is the electric field at a distance r from a point charge?
Yes, teacher, 1 by 4 pi epsilon 0 q by r square.
Very good. 1 by 4 pi epsilon 0 q by r square. Okay. That is written here. Question 1.
So we see that for all points on the sphere of radius r, the magnitude of the electric field strength is the same, and it is directed away from the charge plus q in an outwardly normal direction at each point. Therefore, we see that at each surface point, the electric field strength E is parallel to the area vector dA, which represents the area of an infinitesimally small element on the surface.
See, here first charge is considered, and we know around, see, from this charge electric lines of force passes, and we have considered a sphere of radius r. A sphere, and that sphere is known as a Gaussian sphere, Gaussian surface. For a point charge, we consider a sphere around it at a capital R distance. Suppose this at a distance r. So, surrounding this charge, we have considered a sphere. And why we consider a sphere? Because at equal distance from the charge, at all points, electric field intensity will be same because of this formula. From this formula, we know at a distance r, capital R, from the charge, electric field intensity will be same at all points. At all points on the sphere, electric field intensity is same from this formula. Understand? So, and when we draw a normal to this sphere, this is a sphere, Gaussian sphere, we call it Gaussian sphere. What is the importance of Gaussian sphere? At every point on the Gaussian surface, electric field intensity is same. That is the Gaussian surface. You can't consider any surface. You have to consider a surface where the electric field intensity is same at all points of it. Okay, so that's why we considered a sphere around this charge. Understand? So here, electric field intensity vector E, we have seen it is normal to the sphere. Electric field red line, that is normal to the sphere, and you take a small area through which this electric field line passes. Small area dA is considered, and when you draw a normal to that area, blue line, normal drawn to that area, and electric field, what is the angle between them? Alok, what is the angle between E and dA? Alok? Alok? Alok, what is the angle between E and dA? Gramya, what is the angle?
Carry out with my sir.
Grammatically, what is the angle between E and dA? Electric field is outward normal, and the area vector is also outward drawn normal. They are acting in the same, any point you can take, both E and D will be in the same direction. What is the angle between E and dA? Gramya?
It's 0 degree.
Very good. 0 degree. Angle between E and DA are same because they are acting along the same direction. So angle between them is 0. So E ds cos theta will be E ds. Here DA and E DA. Cos 0 becomes 1. Cos 0 is 1. So let us see next question.
Since E is parallel to vector dA, the electric flux d phi passing through this local element is equal to E dot dA is equal to E dA cos 0, and as cos 0 is equal to 1, d phi is equal to E dA. Let this be equation 2. To find the total electric flux phi through the Gaussian surface, we now integrate d phi. Therefore, phi is equal to integral d phi, and this is equal to integral E dA. The total electric flux can also be referred to as the net electric flux. Since E is constant in magnitude for all points on the Gaussian surface, we have integral E dA is equal to E into integral dA. We know that integral dA is equal to A, which is the area of the Gaussian surface considered. Now, phi is equal to EA. We know that for a spherical surface, which is the Gaussian surface in the present discussion, A is equal to 4 pi r square. Therefore, we have phi is equal to E into 4.
Children, I will explain these steps here. The electric field at a distance r from the charge equation E equal to 1 by 4 pi epsilon 0 q by r square. And we have considered a small surface on the Gaussian surface. Gaussian surface means a surface surrounding the charge where the electric field at every point on the surface is same. That is the Gaussian surface. So here you take an area. Here that electric field will be same. Here you take electric field same at all points because of this formula R. It's same. R, if R is same, electric field is same. Understand? So here sphere is the Gaussian surface. Okay. Then d phi. First we find the small flux passing through this smaller area. Then we find total flux passing through the whole sphere. That we will get by integrating that. So first we find the electric flux, small flux d phi. How will you find? P dot dA. Yesterday we have studied ds. Here they have written dA. That's only difference. So vector E dot dA. Vector symbol is there. Vector that they have written it in dark letters that represent they are vectors. Vector E dot dA. E dot dA is E dA cos theta, and we know as E and dA are in the same direction, theta equal to 0. So cos 0 is 1. So we can write it as E into dA. Equation number 2. Total flux, this is small flux. Therefore, total flux, how will you find? Integrate the expression, integrate the above expression. So phi equal to integrating d phi, we get phi. Then right side also you have to integrate integral EDA. Integral EDA. That is E is same at all points on the Gaussian surface. E is same, so it is taken outside the integral E into integral dA. What is dA here? Integral dA means total area. Integral dA means total area. Total area is 4 pi r square. So what we get? E into 4 pi r square. E into 4 pi r square. We get total flux. Okay, you can continue.
Let this be equation 3.
Yes.
Substitute.
Can you add mega?
Okay. So next step.
Substituting equation 1 in equation 3 and simplifying, we get the net flux phi is equal to q by epsilon naught. Let this be equation 4. We see that the net flux phi is proportional to the charge q enclosed by the Gaussian surface, or
This is the Gauss's law actually. We have done the proof of it, Gauss's law's proof. So, electric field E is equal to 1 by 4 pi epsilon 0 into Q by R square and E ds cos theta integral S ds. Like that is total area. So, we get total area is 4 pi R square. Total flux equal to E into capital A. So, E into 4 pi capital R square. E we have substituted from this. First equation we substituted E 1 by 4 pi epsilon 0 Q by capital R square into area of the sphere 4 pi R square. So 4 pi R square cancel. What we get, children? Q by epsilon 0. That is the proof of Gauss's theorem. The total electric flux, phi means electric flux. The total electric flux enclosing a surface. This is the surface enclosing this charge. The total electric flux enclosing a charge. The total electric flux enclosing a charge is Q by epsilon 0, like epsilon naught, we can say Q by epsilon 0, charge by epsilon 0. What is epsilon 0? Permittivity of free space. Here if it is free space, we take this. If another medium, we have to take epsilon. Understand? If it is free space, we take. So, definition is given with the free space as the medium. So, we got the equation flux phi equal to flux, total flux passing through the Gaussian surface, total flux passing through the closed surface, that's equal to Q by epsilon 0. This is the Gauss's theorem, mathematical equation. Okay, children? So, we can go to our notes now. See, this is the statement and proof, very, very important application, more important than that. I sent the question from the last few years board papers. I sent you some questions. When you search it, you can see so many questions came from Gauss's law. That means it's very important part of Gauss's theorem and its application. So you can first study, you have to, this statement you have to study very well without anything left in that definition. You have to study it very well. The surface integral of the electric field intensity over any closed surface. Here it is a closed surface. The surface integral over the closed surface, and surface integral, integral over the closed surface. The surface integral of the electric field intensity over any closed surface S in free space is equal to 1 by epsilon 0 times the net charge enclosed within the surface. How much charge is enclosed within the surface? That is Q here. Q by epsilon naught. What is Q? The total charge, the net charge enclosed within the surface, that is Q. So, what is the formula we got, children? Surface integral over the closed surface, E dot ds equal to Q by epsilon 0. See, this is the statement. Total flux, the total electric flux is equal to surface integral. How it is read? Surface integral over the closed surface S E dot ds, integral over the closed surface S E dot ds equal to Q by epsilon 0, where Q is the net charge enclosed within the surface. So, now see, if you study this equation, you can state it easily. Well, how will you state integral over the closed surface S E dot ds, vector E dot ds equal to Q by epsilon 0. What is E? Electric field intensity. What is ds? Area, smaller area. What is integral SDS? Total area. Integral SDS, that is the total area of the sphere. Here we have considered a sphere. It can be any other surface also. But electric field on that surface must remain same at every point of it. That is the only condition needed to select a Gaussian surface. And that's equal to Q by epsilon 0. What is Q? Q is the net charge enclosed within the surface. Understand? So we got the formula for Gaussian surface. Integral over the closed surface S E dot ds is equal to q by epsilon 0. Understand? So what is equation for Gauss's theorem? In total flux phi E is equal to integral over the closed surface S E dot ds equal to q by epsilon 0. What is q? Q is the net charge enclosed within the surface. What is epsilon 0? Epsilon 0 is the absolute electrical permittivity of free space. What is E? Electric field intensity. And what is ds? Integral S ds is total area of that surface, Gaussian surface. Okay. And proof also we have seen in that video, we have seen, but again as it is written in notes, I will explain that because you have to, when proof is asked, you have to write in this manner. Okay. So first you have to draw a charge plus q and draw a Gaussian surface surrounding the charge. Draw a charge plus q here and draw a Gaussian surface. Suppose small r is the radius of the Gaussian surface, and you consider a smaller area ds here, and when you draw a normal to this area, that is parallel to E, vector E, positive charge, field lines are drawn outwards, and we know area vector is also perpendicular drawn in the outward direction. So at every point on the surface of the sphere, electric field vector and area vector both are in the same direction. So angle between electric field and area vector are making an angle 0 degree. Okay. So first figure explanation. What all things you are seeing here, that you have to explain. What see here? What all things you see here? Charge. So you have to consider a charge plus q placed at O. Then what is done? Radius. So consider a Gaussian surface surrounding the charge with a radius r. Then what we see here? ds. So you consider a smaller area on the surface of the sphere. Do you draw a normal? You mark the direction of electric field. Both are showing in the same direction. So you can write vector E and vector ds make an angle 0. You have considered a point P here. At point P, what is the flux passing through this smaller area? We consider a smaller area at this point P. And what is the total flux passing through that? You find, then you integrate over the closed surface of the sphere. Then we get the total flux. So that explanation is written here. According to Coulomb's law, E is equal to electric field intensity at any point P on the surface of the sphere, E equal to 1 by 4 pi epsilon 0 q by r square into r cap. Vector E equal to vector symbol r cap. R cap is the unit vector in the direction of electric field. When we write vector here also that representation should be there. Vector where r cap is the unit vector in the direction of electric field. Consider a small area element ds of the sphere around P. Let it be represented by the vector ds, area vector. This is area vector ds. How will you represent area vector? It's area ds into n cap. Area ds into n cap. What is n cap? N cap is the unit vector along the outward drawn normal to the area. N cap is the unit vector along outward drawn normal to the area element. Okay. So we have explained all. These are all explanations of this figure. Next only we are doing the derivation. Electric flux over the area element d phi e along over the smaller area d phi e equal to vector E dot ds. Vector E dot ds we have written. Then r dot n. What is r dot n? R is the unit vector in the direction of electric field. N is the unit vector. N cap is the unit vector in the direction of outward drawn normal. And what is r dot n, children? What is r dot n? Their magnitudes are unity. Direction is same. What is r dot n? Anyone? R dot n. R dot n is equal to 1. Why it is 1? Unit vectors. So magnitude is 1 into cos 0, because r and n are in the same direction. Cos 0 is 1. So r dot n is 1, children. So E dot ds equal to q by 4 pi epsilon 0 ds by r square. You see, now there is no vector. Now this changed to a scalar quantity. And no vector symbol because r dot n is 1. So this is a scalar quantity. Flux is a scalar quantity, children. Even though it is the dot product of two vectors, flux is a scalar quantity. Q by 1 by 4 pi epsilon 0 q by r square into ds we have written. Then integrating over the closed surface area of the sphere, we get the total normal electric flux over the entire sphere. We have to integrate this expression, integral over the closed surface S E dot ds. S no. Okay, 1 by 4 pi epsilon 0 q by r square. E is taken outside because E at every point on the Gaussian surface is same. So it is taken outside the integral S ds. What is integral S ds? Surface area of the total surface area of the sphere. That is 4 pi r square. Total surface area of the sphere 4 pi r square. So 4 pi r square get cancelled. We get q by epsilon 0. So what is the total flux? Phi E is equal to integral over the closed surface S E dot ds is equal to q by epsilon 0, which proves Gauss's theorem. You can ask any doubt, children. Any doubt in this? Or I will ask question. Then I will understand whether you understood it or not. You will not ask doubt. Okay. Adityan left. 26 children only. Okay. Proof of Gauss's theorem. I will ask here. First, explain figure, children. Last two. Adil Krishna, you explain figure. Adil Krishna. Adil Krishna. Explain figure. What will you explain when a figure is drawn like this for proof of Gauss's theorem? Explain. What things you can see here? Please explain. Don't waste time.
Cylinder with radius with.
What is kept? What is the most important thing here? What is the most important thing here? We are studying about what?
Gauss theorem.
Gauss theorem. Gauss theorem, what is first what you have to tell? First thing, what you have to tell?
Surface integral of the electric field intensity.
A charge ആണ് ആദ്യം ഫസ്റ്റ് പറയേണ്ടത് ഈ ചാർജിനെ കുറിച്ചാണ്. We are studying about charge, electric charges. Okay, first you have to tell this charge. Okay, a charge is kept, plus q charge is kept at where?
Center.
Center at a point. Okay. Oh, at a point. Oh. Then what we have to consider? Gaussian surface. At a distance, Gaussian sphere nu parayam. At a distance, what is the distance?
1 by
distance. What is distance from center to this?
vector r.
R, vector r. Okay, r radius r nu parayam madi. Sphere, Gaussian surface of radius r. Okay. Then consider a small area around P. What is the area? How much area is there? How much area we considered? ds. ds is the area. Okay. What is the electric field intensity at this point P? What is the electric field intensity at this point P? It is written in figure. Electric field intensity at this point, P tell. Adul, what is electric field intensity at this point, P? Vector E. Vector E. Vector E the magnitude. Devika, what's the magnitude of vector E? Devika. Devika. Devika.
Yes, ma'am.
What is the magnitude of vector E? At P. P 1 by
1 by 4 pi epsilon 0.
Tell complete.
R cap by R square.
Yes. R cap by R square. Okay, very good. Electric field density at P. Okay. Then next, what is the angle between area vector and area vector is the outward drawn normal. What is the angle between area vector and E? Krishna Sri, what is the angle between area vector and electric field? Krishna Sri. Krishna Sri, Krishna Sri. Meghana, tell what's the angle between area vector and electric field?
Ma'am, is it 0 degree?
Correct, 0 degree. Very good. So, Mitra. Area vector, that is electric field and area vector is taken angle 0. So first we wrote a electric field, then EDS cos theta we have to find out. EDS cos theta. Total, in order to find total flux, we have to integrate the expression integral over the closed surfaces E dot ds. E is written here 1 by 4 pi epsilon 0 q by r square. Integral s ds is the total area of the sphere 4 pi r square. So you can write q by 4 pi epsilon 0 r square into 4 pi r square. So 4 pi r square cancel, we get q by epsilon 0. That is the proof of Gauss's theorem. So what is the equation for Gauss's law, children? I don't know. Megha. What is the equation for Gauss's theorem? Megha Rajeshwara. Megha Rajesh. What is the equation for Gauss's theorem? Neeraj. What is the equation for Gauss's theorem? Neeraj. Neeraj, what is the equation for Gauss's theorem? Flux, total flux. What is the equation for Gauss's theorem? Are you? But then we prove the equation. Integral. Arilla no integral. Nivedita, what is the equation for electric Gauss's theorem? Nivedita.
Yes, teacher. Integral vector E dot vector ds.
Flux phi E equal to integral
vector E dot vector ds is equal to q by epsilon 0.
That is Gauss's theorem. Neeraj, Pavitra, tell what is equation for Gauss's theorem? Pavitra?
Yes, teacher.
Tell
That
the equation.
flux is equal to
Ah.
integral over closed surface. E dot ds is equal to 1 q by epsilon 0.
Q by epsilon 0. Very good. Neeraj, ini para. രണ്ടാളെ കൊണ്ട് പറയിച്ചില്ലേ. നീരജ് പറയൂ. നീരജ്.
Yes, ma'am.
What is the equation for Gauss's law?
പറഞ്ഞതൊന്നും കേട്ടില്ല. Full break ആ വരുന്നത്.
അത് ശരി. നീ അത് നെറ്റ് ശരിയാക്കിട്ടാ, അല്ലാണ്ട് പറ്റില്ല. ഓക്കെ, ഇതാണ് അവർ പറഞ്ഞത് കണ്ട. ടോട്ടൽ ഫ്ലക്സ് ഈക്വൽ ടു ഇന്റഗ്രൽ ഓവർ ദ ക്ലോസ്ഡ് സർഫസ് എസ് ഇ ഡോട്ട് ഡി എസ് ഈക്വൽ ടു ക്യൂ ബൈ എപ്സിലോൺ 0. അപ്പോൾ ഒരു കാര്യം ചെയ്യും, ഈ വീഡിയോ കേട്ടിട്ട് തന്നെ വിളിക്കണം, എന്നിട്ട് ഫുള്ള് എനിക്ക് പറഞ്ഞു തരണം ഗോസസ് ലോവും അതിൻ്റെ പ്രൂഫും കേട്ടോ. ഇത് ഫുള്ള് ബ്രേക്ക് ആയി എന്നല്ല പറഞ്ഞത്. ഓക്കെ, ഋതു പറഞ്ഞ വാട്ട് ഈസ് ദ സ്റ്റേറ്റ്മെന്റ് ഓഫ് ഗോസസ് തിയറം? ഇത് പറഞ്ഞ ഇങ്ങനെ പറഞ്ഞാൽ മതി. ഇന്റഗ്രൽ ഓവർ ദ ക്ലോസ്ഡ് സർഫസ് എസ് ഇ ഡോട്ട് ഡി എസ് ഈക്വൽ ടു ക്യൂ ബൈ എപ്സിലോൺ 0. പ്രൂഫ് സ്റ്റേറ്റ്മെന്റ് എങ്ങനെ വേണമെങ്കിൽ പറയാം. ഡീറ്റെയിൽഡ് പറഞ്ഞില്ലെങ്കിലും ഇന്റഗ്രൽ ഓവർ ദ ക്ലോസ്ഡ് സർഫസ് എസ് ഇ ഡോട്ട് ഡി എസ് ഈക്വൽ ടു ക്യൂ ബൈ എപ്സിലോൺ 0. പറ.
ഇന്റഗ്രൽ ഓവർ ക്ലോസ്ഡ് സർഫസ് എക്സ് എസ് ഇ വെക്ടർ
ഇൻഡു പറയരുത്
ഡോട്ട് ഈക്വൽ ടു ക്യൂ ബൈ എപ്സിലോൺ 0.
സ്റ്റേറ്റ്മെന്റ് അതിന്റെ മാത്തമാറ്റിക്കൽ ഫോം ആണിത് കേട്ടോ. സ്റ്റേറ്റ്മെന്റ് നിങ്ങൾ വീട്ടിലിരുന്ന് പഠിക്കുക. സ്റ്റേറ്റ്മെന്റ് ടീച്ചർ എഴുതാൻ പഠിക്കട്ടോ. അപ്പൊ ഗോസസ് ലോ പ്രൂഫ് പഠിച്ചു കഴിഞ്ഞു. വെരി വെരി ഇമ്പോർട്ടൻറ്റ് ക്വസ്റ്റ്യൻ ആണ്. എല്ലാവരും 2 തവണ എഴുതി പഠിക്കുക കേട്ടോ. ഓക്കെ, തമന്ന ഷാജു, വാട്ട് ഇസ് ദ മാത്തമാറ്റിക്കൽ ഫോം ഓഫ് ഗോസസ് തിയറം? തമന്ന ഷാജു. Tamanna Shaju, tell.
Sir.
What is the mathematical form of Gauss's theorem?
Gauss's theorem.
Flux equal to? നേരത്തെ അവരെ കൊണ്ടൊക്കെ ഞാൻ പറയിച്ചില്ലേ, അതന്നെയാണ്. പറയൂ.
Electric flux is equal to integral of the closed surface E dot ds is equal to Q by epsilon 0.
വെരി ഗുഡ്. അതന്നെയാണ് കേട്ടോ മാത്തമാറ്റിക്കൽ ഫോം എന്ന് പറഞ്ഞാൽ. അതന്നെയാണ് സ്റ്റേറ്റ്മെന്റ്, അതന്നെയാണ്. അത് എക്സ്പ്ലെയിൻ ചെയ്ത് എഴുതിയിട്ടുള്ളൂ. പ്രൂഫ് കാണുമ്പോൾ നമ്മളെ ഇക്വേഷൻ ഇ ഡോട്ട് ഡി എസ് കണ്ടുപിടിക്കണം. എന്നിട്ട് ടോട്ടൽ ഇ ഇൻറ്റു ഇൻ്റഗ്രൽ ഡി എസ്. ഇൻ്റഗ്രൽ ഡി എസ് എന്ന് പറഞ്ഞാൽ ഇൻ്റഗ്രൽ എസ് ഡി എസ് എന്ന് പറഞ്ഞാൽ സർഫസ് ഏരിയ ഓഫ് ദ സ്ഫിയർ. അപ്പോൾ ഈ ഇക്വേഷൻ ആദ്യം എഴുതുക, എന്നിട്ട് 4πr² എഴുതുക. 4πr² ഗെറ്റ് ക്യാൻസൽ, വി ഗെറ്റ് ക്യൂ ബൈ എപ്സിലോൺ 0. ഇറ്റ്സ് ദ പ്രൂഫ്. സോ റൈറ്റ് ആൻഡ് സ്റ്റഡി ചിൽഡ്രൻ. ഇതിൻ്റെ കുറച്ച് ഇമ്പോർട്ടൻറ്റ് പാർട്സ് ആയിട്ട് നോട്ട്സ് ആയിട്ട് വന്നിട്ടുണ്ട്. കുറച്ച് ഇമ്പോർട്ടൻറ്റ് പോയിന്റ്സ്. 5 minutes more. If there are point charges Q1, Q2, Q3, etc. lying inside the surface, each will contribute the electric flux. So here in our case, last case, we have seen only one charge is there. So we write Q by epsilon 0. Instead of one charge, if so many charges are there, all the charges will contribute electric flux. So total flux will be flux due to the first charge, second charge, like that it will be. So what we have to find? Total charge we have to find. If there are so many charges inside the Gaussian surface, the net charge we have to find. So the total flux will be due to the net charge. That is very important point for when you do some application questions and all. You should know the net charge inside the Gaussian surface is considered here. Net charge, all the charges we have to add. If the medium surrounding the charge has a dielectric constant K, then flux equal to Q by K epsilon 0. Because we know epsilon by epsilon 0 is K, that we have studied. If it is another medium, instead of epsilon 0, we have to write K into epsilon 0. Another medium of dielectric constant. If it is having another medium of another value of dielectric constant. For air, dielectric constant is taken as 1. For free space, almost nearly 1 itself we take. So if it is another medium with another dielectric constant K other than air or free space, if it is having Dielectric constant, water, 80 is the dielectric constant. So if it is water, when we consider water, we cannot simply write epsilon 0. We have to write K times epsilon 0 because epsilon is K times epsilon 0. Understand? So instead of epsilon is K times epsilon 0. So we have to write that. So epsilon K is also equal to epsilon R. K epsilon 0, either this way you can write or this way also you can write Q by epsilon R epsilon 0, which is also equal to Q by epsilon. So all these things for doing application questions and all, you must know this, how to express this equation in different form. If there is no net charge within the closed surface, Q will be 0, flux will be 0. That is another important point. If the net charge 1 plus Q, other minus Q is there, that is the total flux, children. If the surface sphere is enclosing 1 plus Q charge and 1 minus Q charge, what is the net charge? Mitra, what is the net charge? 1 plus Q, 1 minus Q is enclosed by the sphere. What is the net charge?
0.
0. So what is the flux? What is the flux through the surface?
0.
That will be 0. Flux will be 0. The electric field on the LHS of the equation is the resultant electric field due to all the charges existing in the space. You see, in the Gaussian equation, that is also another concept which we need to answer some application questions. You can see, just studying Gauss's law, you cannot do that, but you should know what is the left side. You see, left side of the equation, integral E dot ds equal to Q by epsilon 0. Here, this electric field is actually, it can be due to other charges. See, somewhere inside the Gaussian surface one charge is there. If outside the Gaussian surface one charge is there, its electric field also we have to consider. So left side of the equation, you have to consider the electric field due to all the charges, whether it is inside the Gaussian surface, whether it is outside the Gaussian surface. Net electric field is this. In our case, we have considered only one charge, that is inside the Gaussian surface. But if some other cases come, the electric field left side of the equation, the electric field is due to all the charges in the space. Understand? Not only due to the charge inside the Gaussian surface. So that is also an important point. Okay. Then Q, but Q now, it is the net charge inside the Gaussian surface. Q is the net charge inside the Gaussian surface. So all these are notes, important points. Electric field on the LHS of the equation is the resultant electric field due to all the charges existing in the space.